Okay, so this is essentially a speeded up version of the talk I gave for the decadal survey panel that Nancy was just talking about. So essentially about Arecibo and its possible future. So as you know, and has been talked about, the telescope collapsed, and although it was 57 years old, it was still the world-leading radar telescope, which was benefiting planetary sciences, space and atmospheric sciences, and also radio astronomy as passive radio telescope. And I'm going to be discussing why the next generation Arecibo telescope is needed for securing the future of planetary radar science. And a white paper on these science goals will also be published this week for community endorsements. So that will be probably advertised in, for example, DPS mailing list, and I can send also the links to the SBEC committee. Okay, so you probably most are pretty well aware of what radar is used for, but just to give a very brief and fast background. So it can provide range with precision as fine as tens of meters, radial velocity with precision as fine as millimeters per second, which can assist, for example, Yarkovsky effect measurements. It gives you clues of size, spin, and morphology, and can help you detect natural satellites, which are larger than some tens of meters. And at Arecibo, we have been observing up to 125 near-Earth asteroids per year within the last decade, and we have been reporting astrometry for majority of them, which in many cases helps to predict those asteroids' orbits for centuries to come, and it helps them from getting lost. Because, of course, in addition to knowing about the asteroids, we also need to know where they are going. And benefits of Arecibo have been, for a long time, flexible scheduling. We have been doing observations even with one-day notice, because many times these recently discovered asteroids have very short observation windows. So it's very important in terms of the asteroid observations that you don't have to schedule them like weeks or months in advance. And because we are using S-band, which is about 13 centimeter wavelengths, the weather is essentially almost never a problem, except for very occasional hurricane lockdowns. And in the picture, you can see kind of comparison between Arecibo and the Goldstone's DSS-14 and DSS-14 and Green Bank telescopes, kind of comparisons for how the numbers of near-Earth asteroids and what kind of signal-to-noise ratios you can expect for those specific asteroids. In terms of planetary defense, according to Amy Mainzer's white paper that was submitted in the decadal survey, only 1/3 of near-Earth objects with diameter larger than 140 meters have been identified, and currently operational near-Earth object surveys just can't reach the goal of finding them all until at least like several decades to come. And Rubin Observatory and the NEO Surveyor mission are starting to survey, but one radar facility will not be able to keep up. And of course, optical surveys can also track, but the radar can provide very, very fine precision and with just one observation, like pin down the orbits. And the radar system we are proposing here will allow us to observe more than 90% of the virtual impactors during their discovery operation. I'm not going to use a lot of time for this because I only have 10 minutes. It's just like a list of some small body science results for reference. For example, removing 2020 NK1 from the CNEO's entry list very recently. So it had an impact probability of 1 to 70,000, which is higher than most others. And based on these radar observations, we were able to remove it from that list. Also, 2019 OK is a good example of a fast response. Radar provides shape models, Yarkovsky drift detections, binary and three-body system detections. And as we saw yesterday, for example, Dylan Hexon gave a talk on how radar polarimetry observations can be used for studying surfaces of asteroids. And also wider planetary science sense, the Arecibo's Legacy telescope was the only one that was able to observe the surface of Titan and provide high resolution mapping of surfaces of Mercury, Venus, and Mars. And for example, for Venus, you do need these long wavelengths of for example, 13 centimeter S-band waves that you will be able to kind of see through the clouds of Venus. So for example, the Greenbank's new radar would not be able to observe the surface of Venus. And it also allows radar studies of main belt asteroids, comets, Galilean moons, and rings of Saturn, and provided space mission support, for example, transmission for the mini RF. And it was, of course, supposed to be also helping with the DART mission. And rebuilding could return all of these capabilities and bring also new fields of study, such as, for example, space debris tracking, characterization, and particularly in the geostationary orbit. So the idea that we are proposing in the white paper is to build the world-leading radar telescope, which would have 2.5 times more sky coverage than the previous one, more than 4 times the radio signal transmitting power, nearly double the sensitivity, and so on. And this would be a comparison of the different radar systems. So you can see that this next generation Arecibo telescope would be significantly better than anything else that has existed or is being planned. So this one suggests 5 megawatt, 5 gigahertz radar system. And also the zenith angle range would be, in this case, 48 degrees, which we're of course still wondering if it's possible, but that's the science goal for the new telescope. You can see the white paper for like more detailed information about the initial design concept, but the idea is that we would be moving towards phased arrays because they would allow greater radar transmission power than you can use with just single transmitter. And that also would decrease the risk of a single point failure or that just a single radar transmitter would have. And this kind of phasing of the transmitter signal has not been tried in this way or size scale before, so it would really push the technology forward if it was made to work. But it would of course require further engineering studies.
2 more minutes.
Okay, so I'll be focusing mostly on the recommendations. So these are definitely recommendations for long term. This telescope would not be ready to be used in the next just a few years. So it would, this would be definitely a long-term solution. But then if we are looking at the telescopes and radar facilities we have now, we're essentially relying on Goldstone, but it's not a long-term solution to just rely on Goldstone. And also the Greenbank telescope's new radar system will be helpful, but also it should not be the only radar facility. It will have big demand issues and also possible weather dependency because of the frequency that they are going to be using. So with 35 gigahertz in dry air, the system temperature doubles compared to S-band, and it might not be very useful at all in rain. It definitely wouldn't be useful at Arecibo because of the humidity. And also the beam width should be large enough to account for pointing uncertainties in asteroids orbits. So if you have a very high frequency, you would have also a very narrow beam, and it can also be a limitation to observing asteroids. So the new powerful radar facility will also likely depend on the recommendations of the planetary science community, because radar is essentially only beneficial for planetary science. The Astro 2020 is not going to be accepting anymore like a white paper for proposing new Arecibo. NSF just gave a statement today, for example, that they have asked them to not accept new papers so that it doesn't cause delays. But also, I think it's very important that the planetary science community pushes for new radar facilities, because we might not be able to expect from astronomy and astrophysics communities for them to push it, because it's not really necessarily useful for them. And I'd also like to mention that that NASA had already some plans for space object area radar, which would be using X or Ka band. And these radar capabilities we're proposing would be comparable, but the timeline and funding for the SOAR is unclear. So this new telescope could either replace SOAR or speed up the technology development it needs. So if it ever appears, then it could be used as a complementary.